everybody, this is Ryan from Old School Auto again. And as you can see behind me over here, we've got a rear axle. We're doing a little bit of rear axle work today. Let me tell you a little bit about what we got going on here. So this is a Ford 8.8 rear axle out of a 1990s, like late 1990s Ford Explorer. Now the beauty of these is it's an 8.8 rear end, so it's only slightly smaller ring gear diameter than the venerable Ford 9-inch. So the ring and pinion gear are comparably strong, and the Explorer units come with a beefy 31 spline axle, which is actually a larger diameter axle shaft than a lot of the Ford 9-inches that came in passenger cars. A lot of those passenger car 9-inches and early Bronco 9-inches got 28 spline axles, so a 31 spline axle is actually an upgrade over just a factory 9-inch. So even though it's a C-clip axle, it has a groove machined in the end of the axle shaft to be retained by a C-clip in the center of the differential versus a bearing retainer that's press fit on at the hub side. Despite that, it's still an incredibly strong and incredibly beefy axle shaft. And the cool thing about these is the Explorers use a slightly offset differential. You may not be able to see it from the video, but the driver's side is actually 2 inches longer than the passenger side. And this has got a really cool advantage for us homebrew hot rodders like myself, in that you see I've got an extra axle shaft here. What I did is when I was at the pull apart getting this rear axle, I also grabbed an extra short side axle shaft. So what we can end up doing here, the traditional way of narrowing a rear axle is you would drill out these rosette welds, and you'd have to use a press to get the axle tube pressed out of the cast iron center section, or maybe cast steel, I'm not sure which. At any rate, the old way of narrowing would be you'd drill out those rosette welds and you'd press out the axle tube, and then you'd cut off however much axle tube you wanted cut off, and then you have to press the axle shaft or the axle tube back into the housing. You'd have to use a jig to make sure everything was square, and then you'd redo the rosette welds, and probably a lot of times also for 8.8s for strength they would add a bead of weld between the tube and the cast center section. Well, here's the quick and dirty method that we're going to use to narrow this housing. And let me just step into the frame here real quick so I can show you. Okay, so how we can narrow this at home without a jig, without any specialized equipment other than a welder. We're going to take an ordinary piece of C-channel. Now this is obviously a pretty long piece. You only need about a foot and a half of this, and we're going to cut it off. But just for illustration purposes, I'm just going to use this chunk of 2x4 to show you how I would use the C-channel. So what we're going to do is we're going to clean up all the bracketry on this axle, because we're going to need to weld new spring perches on here anyway. We're going to need to get rid of this is where the factory sway bar would have bolted on. So this is going to come off. That's going to come off. All the bracketry we need to clean up and make sure we get a nice clean straight round axle tube. And then what we're going to do is, instead of traditionally cutting this on the end after it's been pulled out, we're going to leave this in the housing, because we know this piece of tubing is in there straight and square. So instead we're going to cut it somewhere in the middle. We want to cut it somewhere probably away from where the spring perch is going to weld on, or where any of the brackets are going to weld on. But somewhere, let's just for argument's sake say we're going to go in the middle of the axle tube. We're going to use a piece of wide masking tape and wrap it around the axle so that we get a nice square cut line. But because if we wrap that tape around there properly and it meets up with itself, then we know we've got a nice square cut. And we're going to put another piece of tape exactly 2 inches away, and we're going to wrap the axle with that. And of course, also before you even tape it or anything, you want to paint or scribe a line along the top so you can get the rotation right when you weld it back together. Anyway, you get your two tapes put on the axle so you have a nice square cut line, and then you're just going to cut that 2-inch section between the two pieces of tape, or better yet, you could use a single piece of 2-inch wide tape and just wrap it around and cut on either side of it. At any rate, you're going to remove a 2-inch section of this axle tube, and this end is going to fall off, of course, after you've taken out the axle shaft and all that stuff. Then to get it back together square, that C channel, it's got the bottom edges of the C are parallel to each other. And by putting a piece on the top of the axle tube and a piece on the bottom of the axle tube and putting a big pair of C clamps on that, it's holding that axle tube together and it's making it parallel itself. So it's kind of a self-aligning fixture at that point. And then once you've got those two pieces of C channel C clamped in place, you want to make sure that your scribe line is in line with itself so that the housing ends aren't being rotated too far. Even if it's a little bit off, it's not a big deal. And then once you've got it all lined up and you're happy with it, just put a couple of tack welds in that axle tube to hold it. And then once you get those tacks in place, you can remove the C channels and rotate them 90 degrees and put in a couple more tacks. And once you've got a handful of tacks, you want to check the straightness of this housing. Running a straight edge along the top of it and along the sides would be a good idea. Leveling the axle tubes, putting a level on the passenger side tube, getting it level, and then using your small level on the outside, making sure this tube is level. Then rotate the housing 90 degrees, check level again. Once you've made sure that it's pretty well straight, take your short axle shaft, slide it in, and roughly reassemble this with the wheel bearing and the C-clip attached and all that, and then rotate the axle shaft and feel for bind. And if our level checks out, if the axle shaft doesn't bind up, chances are we've got this thing pretty well squared up and we've maintained that factory alignment. So then we're just going to go back and we're going to continue adding tacks until we've tacked it all the way around. And as we're tacking it, every once in a while you want to stop and check, do those same kind of checks and make sure you're not warping the housing. And then once you've got a continuous bead of tacks all the way around, that thing's not going to go anywhere. At that point, you can take your welder on a heavier setting and burn it in, put a final pass over top of it. Again, recheck it after everything is done. But if you're careful, you do it slowly and carefully, you should be able to get this back together. And I can't take credit for this kind of a redneck version of axle narrowing. I learned this from YouTube University, and I'm just passing this along to you guys as a thank you for following my channel. But we're going to go ahead, we're going to rip into this and see how well this works out. I've never done this before. We're gonna try it out and see what happens, and hopefully this is going to get us an Explorer axle. The factory width on an Explorer rear axle 8.8 like this measures 59.5 inches, 59.5 inches from wheel mounting surface to wheel mounting surface. The Rambler is 56.5, so by taking 2 inches out of this and narrowing it, we're only going to have a rear end that's 1 inch wider than the factory Rambler rear end. So basically, the width of this in factory configuration is great for 69 up Mustangs, and the narrowed configuration is the perfect width for 68 and older Mustangs, as well as narrower cars like this Rambler. It's a little wide for the Rambler, but it's going to fit in there. And $149 at the pull apart. It's got disc brakes, it's got a parking brake. You got your choice of gear ratios. These late 90s Explorers are ultra plentiful in junkyards. You can get them, there's pretty much not a single junkyard in the country that doesn't have some kind of late 90s or early 2000s Explorer in it, and they're dirt cheap. I paid $149 for this one, complete, and that's from disc to disc with everything, like everything included $149. And a lot of not only do you have your choice of ratio, but a lot of them come with posis. This one is a 327 rear gear because that's what I calculated was going to work good with our 4-liter and AW4 overdrive transmission, because I wanted this car, being that it's going to be my new daily driver, I wanted some really good highway gears, so hence the 327 ratio. Unfortunately, the only 327 rear end in the yard was an open differential, but hey, beggars can't be choosers. But I had a hard time finding a 327. Most of these rear ends were 355s, 373s, and 410s, and they were probably 75% of them were posi type rear ends. So these late 90s Explorers are a great swap vehicle for scavenging parts. A lot of them come with 5-liter V8s and the 4R70W transmission. They've got this Explorer 8.8 with its 31 spline axles, and it's easily narrowed. And if you want to save yourself a couple bucks, here's one little extra tidbit that I didn't think to do myself. While you're in the junkyard, peel the cover off, get that cross pin out, push the axle shaft in, take that C-clip off, and this long side axle shaft is junk anyway. Pitch this thing on the junk pile, and then go get your short side axle shaft, slide the short side axle shaft in there and reassemble this thing. It's going to be the same price whether it's got a long side shaft you're going to throw away or if it's got 2 short side shafts. They don't care. They just know that it's a complete axle. So instead of paying 30 or 40 bucks extra for an axle just so you can throw away a long side shaft, why not throw it away there where you don't have to pay for it? So, and also while you're there, you don't necessarily have to get one rear end. You can cobble your rear end together out of parts that are in there. Find some good brake pads, find the best looking calipers, find some decent looking hoses, because you're going to pay the same amount whether you're going to throw this junk away or whether you're going to reuse it. So might as well, while you're there, find a rear end that's workable and has some good parts on it, and then you can save yourself a lot of dough on the back end when you finally get to reinstall this. What you should also pay attention to is when you're pulling one of these axles, they have a flange style drive shaft yoke. Take a set of snap ring pliers with you and get that yoke, because otherwise you're gonna have to go on Amazon or eBay and get a replacement yoke. And if it's attached to the rear end, they're probably just gonna let it go for the cost of the rear end. Also, I decided to bring along the U-bolts and the U-bolt tie plates because they'll save me some fabrication when it comes time to stuff this into the Rambler. I've already got ready to go tie plates. So I just grabbed as much stuff that was with this as necessary. Pull apart where I got this from, they do charge extra for the e-brake cables. So if you are going to cut the e-brake cables out, cut it upstream from one of the joints, because if you cut the e-brake cables off right at the housing, they're not going to charge you for the e-brake cables. But if you got a long enough piece of e-brake cable, they're going to charge you for it. So might as well not cut something if you're going to have to pay for it and potentially reuse it anyway. I plan to reuse these Explorer cables, so I made sure to cut it way, way, way upstream, almost where it attaches to the e-brake pedal inside the cab, basically where the cable comes out of the cab of the vehicle. That's where I cut it off. And it's got several of these joiners along the way, so I can easily adapt it to the existing parking brake cable on the Rambler and make this all work together. But anyway, that's enough of me running my mouth. I'm going to get into this and start tearing this thing apart so we can get on with the narrowing process. First things first, we're going to strip off everything we possibly can from the housing. That includes brake lines, brake calipers, brake discs, and the brake cables if you can get at them. Once we've got that done, we're going to drain the differential fluid, because in this type of assembly, differential fluid lubricates not only the gears but the wheel bearings, so the axle tubes are full of differential fluid as well. Once all the fluid's drained, we're going to remove the cross pin lock bolt, pull out the cross pin, push the axle shaft in, and remove the C-clip with the magnet. Then we're going to remove all the extraneous brackets from the axle housing. This particular bracket is for the sway bar, but all 4 brackets are going to be removed the same way. We're going to carefully grind out as much of the weld as possible, and using a pry bar, sledgehammer, air hammer, or any other tools you can, we're going to carefully remove the bracket. Primarily, we want to be concerned with not damaging the axle tube, because that's going to be reused, but especially for the spring perches, if you plan to reuse those, be careful when you're removing them so that they don't get damaged beyond repair and can be reused. Once we've removed this one bracket, I'll skip ahead because the removal of the other 3 is the same as the removal of this one. Okay guys, here's the math on our narrowed 8.8. So the looking at the bottom line here, the Rambler rear axle is 56.5 inches wide, wheel mounting surface to wheel mounting surface. Factory Ford Explorer is 59.5. Now we're shortening it based on the using 2 short side axle shafts. We're getting rid of the long side axle shaft, and the short side shaft is 2.87 inches shorter than the long side shaft. So that's how much we have to narrow the housing. So going from 59.5 minus 2.87 equals 56.63 inches wide, and the original Rambler is 56.5. So we're just 0.13 inches wider than factory. So it's practically the same width. That's what makes this swap so awesome. Okay, and here we've got our Explorer 8.8. It is all dressed out and ready to be narrowed. We've got the spring perches ground off and removed, and the mounts for the sway bar have been ground off and removed. And you can see here, I've got some tape marks, and this is 2-inch wide painter's tape. And by wrapping it around so it overlaps with no gap, we know that we've got a straight circumferential line all the way around the axle tube. Now I decided to cut this right here where there's a nasty scar in the axle tube from the sway bar mounts. I mean, I could fill this in with weld from the MIG welder and then grind it smooth, but if I got to cut out a chunk anyway, I might as well cut out the ugly part and I'll just weld it back together. So what we're going to do is we're going to take a zip disc and we're going to, as close as we can, follow the line of this tape with a zip disc and cut off the outer portion of the axle tube. And then we're going to go ahead and we're going to cut it same thing along this inside line. I measured these out with the calipers. It's 2.87 inches almost exactly. That's how much the housing has to be removed. That'll make it just the right width for the new short side axle shaft. Once we get that done, I'm going to take the grinder and I'm going to bevel this edge because this is pretty thick tubing. And if you've taken any welding classes, you know that you want to make this is going to be a multiple pass weld. I'm going to use a series of tack welds with the MIG welder just to start. But once I've got it where it's straight and welded back together and solid, I'm going to burn this in probably with the TIG welder just because the TIG welder does a really nice job. Also for alignment purposes, pardon me, I used this piece of angle iron and laid it on the housing and then scribed a series of lines across so that when I'm putting it back together, I can get these scribe lines to line up so the rotation of this flange out on the end will be the same rotation. And because I did 4 different scribe lines, one on the top, bottom, left, and right, I put a little red paint dot so that I could make sure, because I realized once I'd scribed more than one line, I would be like, oh crap, you know, what rotation does this have to be when I weld it back together? So by having one paint dot on the one scribe line, I know that this scribe line has to meet up with this scribe line. But anyway, we're going to go ahead and start cutting, and then we'll be ready to weld this back together. Okay, well again, my camera didn't do the time-lapse photography here, but you can see I've got the end of the axle tubing cut off, and here's the section that we've cut out of the metal. Got a nice straight cut, followed the tape edges really nicely. And I've also gone ahead and I've beveled this in preparation for welding. And let's just get a little close-up look at this here. So when you're welding something as thick as this is very thick tubing. This is something like 1/4 inch thick. You're going to want to bevel it. There's a flat land that we don't bevel that's going to be about 3/16 of an inch thick, or roughly the width of a TIG welding rod. And what the bevel is going to allow us to do is get good penetration on this so that when we butt the other tubing up against it, we're going to have a nice V groove that we can come in with our welder and we can lay weld bead, and basically we'll be welding this little land that we left. And so once we've tack welded that all the way around, then we've got this nice big groove that we can just lay lots of weld bead in there and fill that in and make it nice and strong. A little bit of extra time spent getting this bevel very nice is going to improve your weld quality. You want to try to keep that bevel, the land of the bevel, the same width all the way around for consistent penetration. And if you spend a little time on the front end with the grinder, your weld quality will be improved immensely. So now I'm going to go ahead and do the same thing. I'm going to bevel the piece of tubing that we cut off, and then I'm going to prepare to weld them together. Here you can see our rear axle is clamped together, ready to be welded. I've gone ahead and beveled both the axle housing tube and the cut off section that we removed in our welding back on. and I've got a couple of 12-inch pieces of C-channel, and these things are clamped really tightly together, and they're making basically a straight edge that's going to hold this tube in alignment with this tube. And you can see I got the remains of my paint mark. It kind of got scraped off from the housing rotating against the jack stand, but the remains of my paint mark and my paint mark over here and the scribe line, you can see is all lined up nicely. So we are ready, and you can see obviously with any cut, it's never going to be exactly perfect. There's like apparently one high spot down in here that's holding a little bit of gap, but generally you do want a bit of a gap when you're welding, butt welding thick metal like this. This actually kind of worked out all right. I actually might pop this apart just now and dress that weld a little bit more so I can get it a closer gap, because I'd rather have it snugged up, touching just barely. I don't know. I'm gonna mess around with this, because when you're welding plate like this, you want to have whatever welding rod that's the thickness of the land that you left in there, you want to be able to slide that welding rod in between. So maybe I'll just leave it as is. I think I probably will. And we're just going to start adding tacks. And as we add the tacks, we're just going to keep making sure that the housing stays, or the tubing rather, stays straight in relation to itself. All right, now it's time to begin tack welding our housing back together. You'll notice that in between every tack, I'm rotating the housing. The idea is that whenever the weld cools, it's going to pull the housing together. So if you start welding on one side, just working your way around, it's gonna warp that housing. So by using a crisscross pattern, the same way you would tighten lug nuts, make sure that as one weld cools, the other weld on the opposite side cools and pulls the housing back into alignment. Once we've got about 6 or 8 tacks, we're just going to keep adding tacks onto the existing tacks in a rotating pattern, just to keep from bending the housing. And here you can see we've got our initial pass. I'm using a MIG welder. While it is a 220 volt MIG welder, I currently only have 25 thousandths wire, so turned up as hot as it'll go. It's still a little bit of a cold weld, but that's really all I need right now. I just need something to hold this together until I can give it a final pass in the TIG. Now, something a lot of guys forget to do is they'll just go right over that existing weld bead with something else. You could use a stick welder too. I'm going to use the TIG because it gives a nicer finished product that requires less cleanup. But anyway, what guys will do is they'll just weld right over that existing bead, and what you really need to do is you'll get a brand new grinding wheel with a nice square edge to it. So usually just a grinding wheel that's never been used, and grind a U-groove. You're just taking the top off that existing weld bead and you're leaving yourself a nice trench to fill in with a capping pass on whatever welder you're going to use. And see, like if you were to just weld on top of the existing bead, you'd get like a mountain of weld bead over top there, and you'd be grinding all day to get rid of it. Whereas with this, I've ground out all that extraneous like lumps of weld that I don't need, and I've left the part where the metal is fused together. And so now when I lay a new weld bead in there, it's going to be just above flush with the top surface of that tube. So it's going to require a lot less grinding on the back end. And it's just going to, again, you get better penetration, a better final product. And this is really the correct, proper way to do it. So I'm going to finish grinding out these welds, and then I'm going to move my welding table out here so I can get the TIG welder on this. And as we begin the welding process with TIG, we see a nice little oops where I accidentally blow a hole to the tubing and have to fill it back in with some welding rod. Just a little lesson. Remember to keep that torch moving if you're going to be burning hot, and we were burning pretty hot, pushing about 250, 300 amps. Once our welding is completed, it's back to the grinder to clean up the weld and blend in the existing metal. This is mostly for cosmetic purposes, but hey, there's no reason it doesn't have to not look good. And that, boys and girls, is how you narrow an 8.8 rear end housing. As you can see, Our TIG welds have been ground down nicely with the flap disc. And once we get a little paint on there, you'll never even know that that was welded back together. I put a straight edge on it. It is perfectly straight. And our axle shaft turns without binding. Now, this may not be as perfectly straight as a factory housing, so maybe you're not going to get 60,000 miles out of a set of rear tires on this. But you know what? If you're worried about wearing out tires on a hot rod, maybe hot rodding isn't for you. This is an old school hot rodder's trick. You can really do it with any axle housing that has a pressed in tube like that. If you can find an axle shaft that's the right length that you want, like if you could find a shorter axle shaft than that, a pair of them, you could narrow both sides. You could make this thing even narrower if you wanted to run some wide tires. But point being, I got about 8 hours of labor in this, and I've narrowed this for just my labor. And you can do it yourself too. Honestly, I've never done this before. It worked out perfectly. It's not hard, guys. So I hope you learned something today. I know I did. This was actually a really fun project, and it feels really cool to get this thing together, have it straight, and have this axle shaft turn with the right amount of stick out. Everything came together on this. Now all we have left to do is we're going to slide the rear end out of the Rambler, slide this rear end in there, and we're going to take those spring perches. I was careful when I cut them off. We're going to reuse those spring perches, and we'll just mock this up in the rear of the Rambler so that we can get a measurement for a drive shaft. And we're going to go junkyard scrounging and try to find a drive shaft that's the right length to fit this without having to cut and narrow or cut and shorten a drive shaft at a drive shaft shop and save that expense. We're just going to spend 25-30 bucks at the junkyard and get a junkyard drive shaft that's the right length. We'll crawl around under some cars with the tape measure and see what we can find. But until then, keep hot rodding, and remember, if you can like, subscribe, and share, it helps me out. And yeah, let your friends know that you can narrow rear end just with the common tools you've got in your garage. We'll catch you next time, guys. Have a good one.